love atoms. We're literally made of them. They're the building blocks of our whole universe. Right? Take this banana, for example, a healthy source of a type of atom called potassium.
The most abundant potassium isotope is potassium-39 and makes up 93% of all potassium. But there is some potassium-40 in there, meaning that the potassium nucleus has one extra neutron, which makes it radioactive. As these few potassium atoms undergo decay, they emit this particle called a positron. What's a positron? Well, not normal matter, that's for sure. A positron is actually part of an entirely different but analogous set of matter called antimatter. When antimatter particles and regular particles come into contact with each other, they annihilate with a burst of energy.
So what is antimatter? Well, to explain, we first must understand the development of quantum mechanics in the early 1900s. Until this point, Newtonian mechanics ruled, but they broke down when one started to study the fundamental particles themselves, not large objects. Physicist Erwin Schrödinger discovered that using wave mechanics to describe an atom's behavior yielded experimentally consistent results. Schrödinger's equation, though, was not consistent with Einstein's widely accepted special theory of relativity. Soon, top physicists developed the Klein-Gordon equation, which is consistent with special relativity, but it had some other problems. Some of which were that it sometimes yielded negative probabilities and didn't allow for different spin states. Paul Dirac, a genius yet eccentric physicist, solved both problems by taking both equations to create his own. All he had to do was to find the alpha and beta values here that would make his equation equivalent to the Klein-Gordon equation. His genius was that he saw that they could not just be numbers, they had to be matrices. Yet, solving this equation yielded two sets of wave functions. This one implies positive energy, but this one implies that the particle would have negative energy, which is definitely contradictory to what their views were at the time. They found that the negative energy solution had all the same properties as the electron, but with a positive charge, and thus they named it the positron. Soon they found tons of antiparticles, and thus the class of particles called antimatter was recorded and proved to be completely analogous to the class of regular matter, but with exactly opposite charges, such as electric charge. But why do we care about antimatter when we clearly live in a universe that is dominated by regular matter?
Have you ever heard of a PET scan? Medical imaging that is commonly used to find cancer. PET stands for positron emission topology. Yep, we use antimatter in medicine.
Though our universe is dominated by normal matter, antimatter still exists. We will never reach the end of discovery of what makes up our universe and how it all works. But isn't that the fun?